From volcanic depths to your glass, witness the rare geological engineering behind naturally carbonated artisanal water.
We'll reveal the hidden journey, borehole extraction, anaerobic filtration, and counter-pressure bottling, where geology meets precision engineering. Follow the journey through high-pressure boreholes, laminar flow pipelines, and the counter-pressure fill that preserves every delicate bubble.
This is the unseen craft. This is the science of purity. This is the journey of artisanal sparkling water.
Notice. This animation reveals the raw power of a volcanic aquifer. Deep within the earth, magma heats water, releasing pressurized CO2.
Here, deep within the volcanic cavern, superheated water rapidly deposits minerals, forming crystals of calcium and magnesium.
Here we see carbon dioxide bubbles forming in the water, rising slowly as they catch the light.
Is held hacked in labs. The natural carbonation on the left produces small, creamy bubbles that rise slowly. In stark contrast,
the water cycle begins deep beneath the surface, rising to the mountain peaks before flowing back to the sea.
Deep within this glacial melt lies a history spanning millennia. Carbon dating reveals the sample's true age, 8,450 years. This visualization shows carbon dioxide molecules dissolving rapidly into the water table, a direct result of industrial activity.
The geothermal gradient illustrates how temperature dramatically increases with depth, reaching 400 degrees Celsius just 5 kilometers beneath the surface.
We need to follow this contour line across the ridge before we start the core sampling sequence shown here. We've positioned the rig right here, overlooking the main valley. It's a challenging spot, but the geology suggests high potential.
Pressure's dropping, increase the pump rate. Acknowledged, bringing it up now. Flow rate is holding steady at 15.3 liters squares. Confirmed, still within the green zone parameters. Utilizing ultrasonic technology, the meter accurately measures the turbulent flow in real time, displaying the volume in cubic meters per second. The stainless steel pipeline carries the flow from the extraction site, heading directly towards the distant bottling facility. From the wellhead, the pipeline snakes across the vast landscape, delivering resources to the facility on the horizon.
As the velocity decreases, the turbulent flow begins to smooth out. The Reynolds number drops, and the fluid enters a laminar state.
This cross-section shows the multimedia filter. Water flows downward through layers of anthracite, sand, and garnet, trapping impurities as it goes. This 0.45 micron filter is undergoing a bubble point test to verify its absolute rating and ensure structural integrity.
On the left, mass-market carbonation creates large, aggressive bubbles, but artisanal water, seen on the right, is defined by millions of tiny, elegant bubbles.
In this persistence test, we compare two formulations. Notice how side B clears much slower than side A. As we can observe in this side-by-side comparison, the smaller 50 to 100 micron bubbles exhibit a much slower rate of ascent than the larger samples.